Yeah. And also thank you for all the speakers. It was really interesting, and a lot of the problems and challenges that everyone just talked about are things that I deal with all the time. So go next slide. Okay, so starting off, it's important to just define scope and scale. And Walmart is big, but it's really how big? Well, there's a recent article that really highlighted just that. It's massive. So anything that we do from a SOC IR perspective, we have to take this into account. Is it feasible? Is it, the computational complexity, is that going to, cause issues for us and so forth? Next slide. Now, just to, clarify what we're saying, threat hunting, this is an offshoot of our incident response team. So these are analysts that have, I'd say more skill, more experience in our domain, and are now pivoting to look for new things within our environment that may not necessarily be caught by our tools or existing procedures. However, like I was saying before, the scale's a problem. Not only do we need, very well-experienced individuals, it's simply not a problem of, well, let's just add more analysts to it to make it better. They have to have experience. And then on the flip side, when you look at it from an automation or ML perspective, we've hit roadblocks. Typically, the products or tools that we have just aren't really anywhere in comparison. So, next slide. And then to just go into like a little more from a machine learning perspective, just the challenges that we see in our area. And I won't go through all of these, but the important ones to me, like alert fatigue, it's imperative that, whatever we're producing, it's feasible. I had a model that was extremely accurate. I think it was like 99% accurate trying to find something, but that would still leave roughly 50,000 false positives in a month time frame. And it's like, I can't expect my analysts to really use that. And also, like the last bullet point, demystifying data science. You have to think about the audience that is utilizing your tools, because, for example, with incident response or a hunt team, these are very smart people that are typically used to being subject matter experts, and they know exactly, from a technical standpoint, what they're working with. So if I come to them with a neural network and I say, it's a black box, just trust me, it works. The adoption of that they're not going to use it. So what, for our approach has been really, bringing people along, trying to explain it as much as I can, to then encourage that use. So this project really started, so I'm on the UEBA team, so the User Entity Behavior Analytics, and we had some success with several, processes on other aspects of our area. We really wanted to apply it to SOC or IR log data. Essentially, the short description of UEBA is we baseline behaviors, and then we try and find deviations from those behaviors and use that as a way for measuring, anomalies or odd behavior. So when we first approached this problem, we wanted to start with ground truths, things that we would expect to see. So in this instance, we could say like lateral movement. We know we're going to see something there that would, within our environment, either RDP, net commands, schedule tasks, what have you. But then also like flexibility, because the problem we're trying to solve for is dynamic. It's constantly changing. And whatever tool or process or anything that we develop, it needs to be ready for that. Data-centric, meaning that's just from my background is in data. So a lot of data engineering, visualization, all that fun stuff. So typically when I'm trying to solve a problem with machine learning, I tend to go for how can I make the data better to fit this model versus trying to make the model fit my data. Next slide. And so this was this approach was coined by my peer Chris, And he hit the nail on the head, where we're taking different models and trying to represent various aspects of the data or behaviors, and then by putting them together to find, what combination is going to show us, odd activity or behavior. So next slide. And our approach, this goes back to, I would assume that the incident response analysts have much more domain knowledge than me. These are, they've been with the company decades in some cases. And so I made a valiant effort to reduce as much of the, bias from my standpoint up front. What am I filtering out? A lot of collaboration with them in order to, make sure that I'm not unknowingly removing something that is serious. And from our front end perspective, we're also, using it as we're falsifying data, right? As we're going through and reviewing the activity, we're then working with the analysts and showing like what we can exclude, because we know it's it's a AUP or an acceptable use of whatever it is. Next slide. Now we'll go into detail, but this was just a few of the models that we used. And a few things that are really important from my perspective is like computational complexity, because if it's, easy, then I can do it at scale. Also, I'm not really looking for something that's going to be what I would call like the silver bullet, where it's just perfect at predicting. At best, a lot of what we have are just what I refer to as like weak predictors. Just based on themselves, it's nothing great. But when we look at them collectively, that paints a much better picture. For example, time of day, if I see activity occurring for a user or a machine that's, in the middle of the night, and it's also, maybe it's somewhat resemblant of a threat actor behavior, that is interesting to me. Next slide. So here, this was an example. So the front end for this process is through Tableau. We visualize it, and each of these dots would represent a user. And essentially, it's the Y column is the score, with the X axis being, I think, dates. Go ahead and go to the next slide. And what we're showing, we can't show too much, but this was where we're deselecting a certain model, or we're removing input from one of the different models we had, and it would adjust everybody's score to then represent how it would look, with that filtered data. Next slide. So this was an example, and it's the red dot on the far right. This was from our red team, which I'll have to definitely shout out to our red team. It's incredibly helpful to have their input, and a lot of what you're seeing here is a result of it. But they had an engagement where they were trying to be noisy in our environment just to see like what would happen. And it was exciting because it showed up relatively high on our process. Next slide. So, there are some positives here, but there are definitely limitations. First and foremost, the dynamic capabilities of the front end has I'd say a con is being, as it's adjusting, it's difficult to really compare to other, time frames, or even, once we have the data updated, it can be tedious. Currently, we're still reviewing the data manually. It's considerably reduced, from a scale perspective, but we're still having to rely on that domain knowledge from our analysts. And and then next. Oh, go ahead. Next slide. And so that's why we're here. We've had some great success with this, and we want to continue pushing it forward, and felt that this would be a great opportunity to share a little bit more than we typically do, but then at the same time, right, get suggestions, feedback. I think it's been a lot of really cool things already shared today. So, and also I would say that typically when we look at commercial solutions for ML, they just don't hold up. in terms of scale, or we have challenges with, they're too generalized, or they just don't fit our environment. So anyways, I think that's it. Yes, thank you.
So you mentioned the false positive rate, that you can have a 99% accurate model and then that's still not good enough. And this is very true. And this is a big problem with people presenting machine learning models for intrusion detection systems. But what would you consider? What would you consider an acceptable level of false positives?
Yeah, no, good question. I think it's dependent on your. So in that scenario, it's dependent on how many SOC analysts I have, and like what is the expectation on their standpoint? Do I expect them? Because I think I broke it down. It was like 1,500 false positive alerts a day. So, if I have 5 analysts, that's a lot, and it means then you think of from a likelihood, how likely are they to miss the true positive? Because it would probably just be 1 alert or maybe 2 if we're lucky, and that's the scary part. So.
Because sometimes it seems like, since the base rate is so extremely low for anomalous behavior, that it almost seems that your accuracy needs to be at the scale of 99.99999 almost.
Yeah, and in that particular scenario, it kind of relates to this, where we're looking at that. We're looking at that independently, but then other factors or other behaviors that would then we can use to reduce that, false positive rate.
Yeah.
Following in on that, Grain, one of the things that I've always found is that it's not just the accuracy, right? I mean, the thing is, if you're detecting new things that SOC analysts aren't doing themselves, then you are helping them, even if there's some false positives sneaking through. The trick to me has always been, how do you prioritize the list of things that you're passing through so that the most important ones bubble to the top? Because they're going to get 10,000 whether it comes from a non-intelligent system versus an intelligent system. You still have to give them, here are the top 10 that you should look at right now, right? Do any of your systems do that kind of approach? Or?
Yeah, actually, yes. So I think it was Anoop that discussed risk. So that is exactly what we try to do, is to define risk and then use that as a way of prioritizing, because for one, it's complicated. There's a lot to it. And then 2, it's dynamic. It's constantly changing, because our interpretation of risk changes over time versus what are we reading, or what's, happening, or do we have a new tool that's monitoring something that we feel comfortable with and whatnot. So yeah, definitely. We try to do that as best as we can. So
I just wanted to riff off this question a little bit.
Sure.
And you showed these very interesting graphs, and you said our red team was being particularly noisy, and we could see them show up, and they were essentially having a very risky posture through this noisy mechanism. It's always easy to find these noisy folks. And I'm wondering, do you have any experience in stealth, in terms of how effective are ML tools for stealth? Because I feel that's particularly hard.
Yeah, it's extremely hard. Yeah, and I made sure to say that they were being noisy, because typically they're not, and they're very sneaky. So for that, it's almost a case by case, and I would almost say that's what the domain knowledge is so imperative, because they're the ones that are going to see the very odd, abnormal thing. But if I can do my job well enough to where I'm prioritizing, and maybe if I make that problem a little bit more manageable, so instead of hundreds of thousands of alerts, maybe there's 100 or 50, then our chances of finding it are increased. So.
So first of all, thank you for the talk. I think it's an important problem, and one that all analysts face is that of very high false positives. If you're able to manage it to 1,500 per day, I think it's a very low number. So congratulations on that already. So you know that this problem will not be solved completely. There will always be false positives, but it is all about what you're doing with them, or how are you finding the root cause analysis of what is causing these high false positives? Are they, of the same category, or is this something which can be dealt with improved, training of your machine learning models, or how often are you training your machine learning models? Those kind of things you can continuously, you try to do, integrate your machine learning models with some rule-based approaches. But at the same time, what are you doing with these these false positives? Maybe I'm more curious to hear before we can.
Yeah, so it kind of depends. So typically, a lot of it is with collaborating with analysts and really determining, like, is it truly abnormal? And the other aspect too about this as well is, we're trying to find threat actors, but I always joke, it's like we always find something, right? Because there are a lot of similarities to, like, I heard shadow IT, the business out in nowhere that's doing something, out of policy. So in that case, that would be, quote unquote, a false positive from the perspective of a threat actor, but it's still something that's of significance. So again, it just depends on a lot of work, collaboration with the analysts, also understanding, what are the low-hanging fruits. I heard that as well. How can we solve that from a rules-based perspective or a policy versus, maybe we can use this output for this model that still has a pretty high false positive rate as a feature for something like a neural network or, that was what I would love to be doing. So that's my next goal, knock on wood, if I can get it done.
So being an academic and a researcher, there's one avenue that you and your team probably might be interested in looking into is what is causing these false alerts. What are the features that are getting surfaced which your otherwise trained machine learning model has not been able to identify the pattern of? What are those new features that, and for that there is explainable AI in specifically for enterprise, system logs, enterprise network logs or system logs, whatever you are using to, in your analysis, whatever you're using. So that's something that we can talk about.
Okay.
Yeah, and you talk about going off the baseline for your model. Could you talk a little bit about how you use development to sort of let the baseline activity is?
Yeah, so it's really dependent on the data set. So a good example the one I usually always give is like looking at like login activity, but for like a user. So we typically will create what we call like time boxing. So we say, here's a threshold. We think, Chris usually is on from 9 to 5, Monday through Friday. So we can use that as our, threshold. And then anything outside of that, we see logins, at 2 o'clock in the morning or whatever, it gives us an easy way to just measure distance and say that's abnormal. We could also look at that from an agent perspective. When do we typically expect the agent to be on the computer or the computer to be online or whatnot? With other things, it just depends. It really is. It's challenging, is a good way to put it.
Yeah, I'm gonna bounce back on the false positive reduction problem that was talked earlier. Have you tried something around the length of try to cluster every anomalies that you would have in your model that's producing a high rate of not very high rate, but, false positive, in order to just regroup those alerts in just for the analyst to try and see which ones are maybe less common alerts than other,
Yeah, no, that's a good point. That is something we're also considering as well, is like putting it into like a process where it's taken as like a feature and then some kind of like clustering or, there's so many other ways to go with it. But yeah, to us, that'd probably be like the next step, is to try and, get it to refine it down. Also by, adding other aspects, other behaviors, other things we can use to, reduce the false positive rate.
Yeah. And in terms of features, and try to see which features are used by the model to trigger if there's an anomaly or not. You could maybe check for shapely values. There's a common problem. So there's one solution maybe. You could
Okay.
try and see.
Well, thank you.